Alright gang, here we go. This is for Physics Unit 8, Part 8, video number 2. We're talking about diffraction. In the previous video we talked all about interference. Alright, and we talked about how you could have, we specifically talked a lot about double slit interference. Alright, so now we're going to talk about a specific application of that called diffraction. Alright, and you actually see diffraction occur all the time around you. Alright, so diffraction, so let's think about this for a second. Diffraction occurs whenever your wave changes directions when they encounter an obstacle or pass through an opening. All right, so if you're talking to somebody that's on the other side of a tree and the tree is blocking each of you, you know that if that person talks, you can still hear them talk. And that's because the sound waves have literally been bent around the tree. They literally go and travel around the tree. And so like if you see, light pass, there's a doorway right here, and I can see light getting bounced off this window that comes around the corner. I can still see the light from that window, even though the window is blocked by the door frame. All right, and that light is still somehow illuminating part of this room. So this occurs because of diffraction. All right. Now, diffraction occurs to a much greater extent when the wavelength and the opening size are appropriate. All right. So if you have openings that have a much larger opening than the wavelength, you really don't see much diffraction. So like this light coming through the door, you really don't see much diffraction going on. It is occurring, but it happens very minimally. All right. So for example, here you've got this washer. All right. It looks more like a nut to me, but whatever. So you got this washer here. Maybe. I don't know, whatever. Okay, and so you got diffraction patterns that are forming. So you got some monochromatic light that's being shown on this washer, and you can actually see diffraction patterns happening. You can see construction and destructive interference occurring as the light bends around the washer. You might say, well, this kind of looks like if you drop this washer into a puddle, right? And you could see waves, and you could see this constructive and destructive interference. And yes, that's exactly right, because waves and light, waves in a pond and waves, the light waves themselves, constructively and destructively interfere exactly the same way. And so you get this diffraction occurring, where you get constructive, this would be that bright spot right there, and then destructive interference would be that black spot right there. All right, and you can see this happening all the way around it. All right, so single slit interference. So before we talked about double slit interference, and we talked about how light passing through two tiny slits can form this pattern of light and dark fringes. All right, now if you have a single slit that's sufficiently small enough, okay, you can actually have interference occurring by light coming through. And so this occurs because one part of the wave interferes with the other part. So here we've got a single slit and 5 points. Each of these points is producing its own wave. All right, the center would be a bright fringe still. So you've got this this view screen here that's supposed to be here, and you've got a bright spot right here. So this would be a bright spot right in the middle. All right, and this occurs because 3, 1, and 5 all travel the same distance to this spot as do 2 and 4, and so you get this really, really bright spot right in the middle. And then you'll also have destructive and constructive fringes occurring, and it all depends upon these wavelengths of light, just like it did with double slit interference. All right, so here's our same guys here, 1 through 5 here, and so if you have some point that's above this center line, okay, so here we're talking about this line right here at number 1. All right, and so at this point, okay, your waves at 3, okay, it will travel 1/2 wavelength farther than those that came from slide 1, okay, and so ones at 5 will travel 1/2 farther than they did at 3, or 1 full wavelength. So you'll get constructive interference, okay, when these collide. But 2 and 4, okay, will have differences. All right, so at the specific angle that's shown, destructive interference occurs, and your wavelength and the screen would be dark. All right, so that would be specifically at this spot. All right, so So in class, we'll look at this really awesome demo, or this lab where you'll actually be able to measure the width of a human hair using a laser. So if you take a laser and you shine it at a screen, and you put a pin in the way, like around the head of a round pin, and you put it between the lasers, so then you just set it there, so the laser hits that pin and travels right through it, past it, and you would expect to see the shadow right on the screen. But not only that, but you would see in the middle of that shadow, you would see a bright spot. Okay, and that bright spot occurs because the light that passed around the head of the pin both had to travel equal distances to reach the middle because of that diffraction. And because of that, you actually get a bright spot in the middle of your screen. All right, and we can also use diffraction gratings. These are we've looked at these a couple of times. Okay, and we probably use them when you were in chemistry. You probably use them quite a bit. Okay. And so in a diffraction grating, you actually have many slits that are very, very close to one another. And so it behaves like a double slit, but the maximum and the minimum are much brighter. Okay, so if you send monochromatic light through there, all right, so like a laser beam, all right, or something like that, okay, or pass it through so only a certain colored light will go through, then you'll get these bright and dark fringes. And so here they've used a lens. Okay, so you've got your diffraction grating, and then they use this lens to converge it all into a specific point with this screen. All right, and they've been able to calculate this angle. All right, and so if you shine white light through a diffraction grating, you'll produce a full spectrum of colors, whereas if you send through just a single monochromatic light, then you would just see bright and dark fringes of specifically whatever color you were looking at. All right. So diffraction gradients, the big use that they have are these in spectrometers, and this is probably what you used in Chem 1 at least once or twice. All right, and so these are used as spectrometers, and they separate this light into its component colors. So you start with a specific color, and then it's separated into this yellow, green, teal, and purple. And so notice you got your zero order, okay, right here. So this is at the brightest spot, and then at the first order you get these four colors, and the second order you get the same four colors, and as you get farther out, they get spread out more and more. All right, so these are used specifically to help us look at the makeup of distant stars, because we talked about that each element has its own order, and it has its own electron energy levels. And so when the electrons get excited and then come back down, they'll come out as different wavelengths. And we use these diffraction gratings. You could actually see, if you remember back when we looked at the the elements, you could actually see the individual lines. All right, and so that's essentially how it's working. Is you're taking this little piece here, and with all these individual little slits in it, be able to shine light through it, and then it gets bent, and because of the different wavelengths, they get split up from one another. And so each element has its own specific fingerprint of diffraction. And it's pretty fascinating. We can use this to help us identify what an unknown might be. All right, and so we can actually take light from other stars and be able to send them through diffraction grating and be able to figure out, well, what kind of elements are in there in that star or that atmosphere of that planet, and so on and so forth. Anyway, so let me know if you have any questions, and I'll see you on the flip side.